Trenching work is one of the most hazardous types of work done in the construction industry. The fatality rate for trenching work is estimated to be 112% greater than the rate for construction work in general. The primary hazard is a cave-in, which can crush or suffocate a worker. It's estimated that at least 73 persons are killed each year in cave-in accidents, and for each fatal accident, there are 50 more non-fatal accidents. Trenching is performed primarily by utility contractors who construct gas, sewer, water, and utility lines. A trench is a narrow excavation made below the surface of the ground in which the depth is greater than the width not exceeding 15 feet. The majority of trench collapse injuries happen in trenches 10 to 15 feet deep with any of the following contributing factors: lack of any shoring, sides cut vertically or undercut, spoils piled too close, machinery or vehicles parked too close, loose or sandy soils, and accumulating water. No matter how many trenching jobs have been done in the past, each job should be approached with the utmost care and preparation. Many on-the-job accidents are a direct result of inadequate initial planning. Correcting mistakes after work has begun slows down the operation, adds to the cost, and increases the possibility of a trenching failure. It's a good idea to develop safety checklists before even beginning the trenching job to make certain there is adequate information about the job site. These specific site conditions should be taken into account because they all could be potential safety hazards for workers during a trenching job. Traffic, nearness of structures and their conditions, soil, surface and groundwater, overhead and underground utilities, and the weather. These and other conditions can be determined by job site studies, observations, test borings for soil type, and consultations with local officials and utility companies. Decide which type of equipment will work best for your particular trenching job. There are 4 basic types of equipment available for trenching work: a backhoe, dragline, wheel trencher, and bucket line trencher. Each machine has its own advantages and disadvantages. Use the right equipment as determined by qualified and authorized personnel. And remember, no worker should operate a piece of equipment without first being properly trained to handle it and fully alerted to its potential hazards. Wear the proper safety equipment for the hazards you face. A safety hat for protection from falling rocks or dirt. Goggles or safety glasses to protect your eyes. Gloves to protect your hands. Steel-toed safety shoes to protect your feet, and any other special clothing or equipment you might need. Workers should all be properly trained in the use and fit of the prescribed protective gear and equipment. Spoil or excavated material can cause trench collapse. Don't let it accumulate near trench wall sides. Always store excavated material at least 2 feet from the edge of a trench. During any trenching operation, the ground must be watched closely to prevent cave-ins. A cave-in occurs when an unsupported wall is weakened or undermined by too much weight or pressure or an unstable bottom. One of the danger signs is surface cracking in the ground nearby. These cracks usually occur near the edge of the trench. If any cracks are noticed, the trenching operation must be stopped and workers removed from the trench. Other danger signs include overhangs and bulges. An overhang at the top or a bulge in a wall can cause soil to topple or slide into the trench. If these conditions occur, stop work immediately to remove the workers from the trench and report the problem to your supervisor. Obstacles such as carelessly placed tools and equipment or excavated material can cause injuries due to slips, trips, or falls. Keep materials or equipment that might fall or roll into a trench at least 2 feet from the edge of the trench. Use warning systems such as mobile equipment barricades, hand or mechanical signals, or stop logs to alert operators of the edge of the trench. To avoid being struck by any spillage or falling materials, workers must stand away from vehicles being loaded or unloaded, and never stand under loads being handled by lifting or digging equipment. No emergency procedures in case of an accident. It is important to incorporate procedures for fast notification of accidents, too. Have emergency numbers and telephone handy, and have someone outside the trench ready to help if necessary. Workers should know basic first aid, CPR, and how to use rescue equipment, and know the escape routes. Ladders, steps, or ramps must be placed within 25 feet of any workers in trenches 4 feet deep or more. Next time we'll talk about the use of trench sloping, shoring, and shields to guard against cave-ins. This is Claude Akins, reminding you that safety is your job too. Trenching jobs are among the most hazardous of construction work sites. The primary hazard is a cave-in, which can crush or suffocate workers. We've already taken a look at preparing a safety checklist for a trenching job, trenching equipment, worker safety gear, spoil, site protection, and emergency procedures. Now, let's take a look at several different methods that can be used to protect the worker against trench cave-ins. Most of the cave-in fatalities that occur each year happen because the trench had no protection in place to guard against a cave-in. These accidents could have been prevented if proper protection had been used. Designing a protective system can be complex because of the number of factors involved: soil classification, depth of cut, water content of the soil, changes due to weather and climate, or other operations in the vicinity. The following trench protective information only applies to trenches 20 feet or less in depth. There are two site conditions that do not require the installation and use of a protective system before allowing workers into the trench. The first is when a trench is made entirely in stable rock. The second is when the trench is less than 5 feet deep and a competent person has examined the ground and found no indication of a potential cave-in. Only in these two cases can the trench be cut with vertical sides without the installation and use of a protective system. If the trench is to be more than 5 feet deep in soil that is not entirely stable rock and/or there is a potential for a cave-in, then the trench must be sloped, shored, or shielded for safe entry into the trench. The sides of the trench can be sloped so that soil won't slide to prevent cave-ins. The maximum allowable slope is the steepest angle from the horizontal at which trench walls will lie without sliding. Slope can be expressed as the ratio of horizontal distance to vertical rise. The more unstable the soil, the flatter the slope should be. For example, the sides can be vertical or 90 degrees for stable rock, 3/4 to 1 or 53 degrees for type A average soil, 1 to 1 for 45 degrees for type B cohesive soil, 1 1/2 to 1 or 34 degrees for type C loose soil or sand. Check local and federal regulations for ground sloping measurements. One method of ensuring the safety and protection of workers in a trench is to slope the sides to an angle not steeper than 1 1/2 horizontal to 1 vertical, which is 34 degrees measured from the horizontal. A slope of this gradation or less is considered safe for any type of soil. Trench shoring and sheeting is another option for protection against cave-in. Shoring means a structure such as a metal, hydraulic, mechanical, or timber shoring system that supports the sides of a trench. Sheeting means the members of a shoring system that retain the earth in position and in turn are supported by other members of the shoring system. Use sheeting made of timber, aluminum, steel, or other approved and engineered materials, bracing and jacks, hydraulic or screw, to support trench walls, as determined by qualified and authorized personnel. Check with your shoring engineer or local and federal safety regulations on trench shoring before any shoring is done. These regulations will spell out very clearly how far the shoring must be set apart and how thick the sheeting must be at various trench depths. Use only materials in good condition. Don't use shoring to support heavy equipment. Use heavier shoring materials for trenches to be left open over a long period of time. Use special care removing shoring from the bottom up using lifting tackle or jacks. A trench shield or box can be used as long as it is not subjected to loads exceeding those which the system was designed to withstand. A trench shield is a heavy frame, often made of steel, to which steel plates are bolted or welded. Shields can be permanent structures or can be designed to be portable and moved along as the trench work progresses. A shield is especially useful for sewer and pipeline work because it allows prompt backfilling. Weather and climate may call for stronger shoring, extra bracing, or steeper sloping. Watch for water flow from rain, groundwater, storm drains, or damaged water lines, all of which can loosen soil and increase pressure on trench walls. Workers should not be in trenches where water has accumulated or is accumulating unless adequate protection has been taken. A competent person must inspect trenches subject to runoffs from heavy rains. Very dry weather can also be dangerous because it tends to loosen soil. Frozen ground can thaw and weaken the walls of the trench. Watch out for heavy loads. Heavy equipment, pipes, or timbers can exert great pressure on trench walls. Keep them as far back as possible from the trench site. Also, vibrations from moving machinery or nearby traffic can loosen soil and cause walls to collapse, especially when proper trench shoring or sloping is not used. Daily inspection of trenches, adjacent areas, and protective systems should be made by a competent person for evidence of a situation that could result in possible cave-ins or other hazardous conditions. The inspection should be conducted prior to the start of work and as needed throughout the shift. Always have a safety-first attitude during trenching operations to avoid tragedy. And this is Claude Akins reminding you that safety is your job too.
There are many types of motorized equipment used on our job sites. There are forklifts, backhoes, trenchers, aerial man lifts, bucket trucks, crane trucks, and cherry pickers, to name a few. It is our objective to ensure that each operator of any motorized equipment at Dashiell Dacon Corporation is competent to operate that equipment safely and proficiently. Only trained, qualified, and authorized personnel shall operate motorized equipment. Qualifications of an employee's ability to safely operate motorized equipment shall be reviewed and approved by their supervisor.